Hi and welcome to my PlatformCon 2022 talk entitled Using Open Source Software to Secure Cloud Native Applications. My name's Chris Tomkins. I work for Tigera, who are the primary contributor to Project Calico. So this is a very short session today. Let's share my screen and dive in. So just a little bit about this talk first of all. Cloud native microservices applications are easy to deploy and they bring immense advantages, but they bring some challenges in terms of security. I see people make difficult decisions about how to implement security for those applications, and I wanted to bring some insights today. So briefly, what's Project Calico? Well, it's an open source networking and network security solution for virtual machines, containers, and host-based workloads. There's a lot more to say, but it's a short session, so just to let you know, we have around 6,000, over 6,000 Slack channel members, over 150 contributors, and over 1 million Kubernetes nodes powered by Calico every day. There's lots of socials that you can get in touch with us there, and there's one other number we're proud of, which is we have more than 1 billion downloads of our per host agent from Docker Hub, which we're immensely proud of. So let's dive straight into the content. A little bit about the Kubernetes network model first of all. So Kubernetes defines a network model, but it doesn't implement it. It relies on another technology to implement it. But first of all, let's look at what that network model defines. Well, first of all, it says that you have multiple containers in a cluster, and those exist inside pods. So you can have more than one container inside a pod. For example, here we see pod A with 2 containers within it. And the first rule is that pods have a single IP per pod, and containers within a pod share the IP address with other containers within that pod. The next rule is that it's a simple, flat, rooted layer 3 network, and that means that every single pod can reach any other pod with the IP address, and there must be no network address translation, which is shown with the red icons here, showing the fact that there's no network address translation within the cluster. There are other rules, but these are the primary rules of the Kubernetes network model. It's up to a chain of CNIs, which are container network interfaces, to actually implement that networking. Kubernetes doesn't care about how it's implemented, it just mandates that the networking should look like that. So a CNI might implement lots of features that you care about from a security perspective. It might implement encryption on the wire, it might implement Kubernetes network policies, or more advanced extended functionality like Calico security policies. It might implement encapsulation or other scalability solutions. So let's talk, before we move on, let's talk about what the challenge actually is then about choosing a CNI. When getting started with Kubernetes, CNIs sound difficult, they sound complicated, and so people will often think that they just want the minimal functional case to get started. As a result, people often choose the simplest they can, and they have this idea of retrofitting security. Now, anyone who's tried to retrofit security in any context, even going back to a data center, will know that retrofitting security onto a running environment is much harder than putting it in place from day one. Changing CNIs on a running cluster is not trivial, and retrofitting security onto a running environment is very difficult. Luckily, the solution is that the barriers to starting with the most widely deployed feature-rich Kubernetes CNI are very low nowadays, so it's actually quite easy to get started with a CNI like Calico that offers a great deal more functionality than the basic. Our documentation linked there provides plenty of resources. There are other CNIs though, so I wanted to take a moment to just point out what you might care about when you're choosing a Kubernetes CNI, specifically with regards to a secure environment. You might have other considerations too, but I focused on those that are related to security. By the way, before we move on, I should just say that as part of PlatformCon, this talk is part of the Platform Tech track, and if you want to join in the conversation, you can go to the Platform Tech channel on the PlatformCon Slack and join us there. So with that said, key CNI considerations for a secure environment. Well, the first one is that you have a trusted network policy implementation. I haven't really spoken about network policy. I'll talk about it more in a moment, but it's the network filtering technology that Kubernetes mandates that the CNI can choose to implement. Not all CNIs implement network policy. That's a really important thing to note. So Kubernetes has this concept of network policy, but not all CNIs implement it. Then you might want more advanced functionality which extends and fills in the blanks which are missing from network policy for Kubernetes. Calico calls that security policy, and Kubernetes will have some more advanced functionality coming in the future called admin network policy that you can rest assured Calico will support. Your CNI might implement encryption to protect data in flight between pods and nodes. And you're also going to want a CNI that has an active community to ensure that issues will be resolved and that you have a community that you can learn from, share learnings and so on, and have some confidence in numbers. Now note that I think Calico does a good job of meeting all of these expectations, but I think this is a great list to compare any CNI that you're evaluating for a secure environment against. So I've mentioned network policy a couple of times. What is network policy? Well, first of all, Kubernetes network policy. We mentioned how Kubernetes defines a simple flat network, but that flat network doesn't imply any kind of isolation. What Kubernetes does is it has a construct called a network policy, and it relies on the CNI to take those rules and to translate them into the networking environment for the Kubernetes cluster in whatever way is most appropriate that the CNI deems fit. Usually that means that the policy will be deployed on the nodes spread out throughout the whole cluster. And that's great because it means that things will scale very far. Isolation is not defined by the structure of the network, it's defined by network policy, and that's implemented by the CNI. Remember, not all CNIs implement network policy. So if we look at an example of a Kubernetes network policy, we can see that the API version, networking.k8s.io, and the kind, these together tell us that this is a Kubernetes network policy as opposed to something else. You can see that it matches some pods based on an arbitrary label called color, and it matches some target pods with another label, and it allows a port. So that's all well and good. Calico network policy, which I referred to earlier as security policy, you can see that the API version here is different. It's projectcalico.org, but you still have something called a network policy and something called a global network policy. So you can think of these as a superset of the functionality of Kubernetes network policy. They do everything that Kubernetes network policy does, but they add some features that are really nice to have or essential depending on your application. I could spend a lot longer talking about this slide, but broadly, given the amount of time we have, you can consider that Kubernetes network policy offers those features in the left-hand column, and Calico network policy adds on a load of other features, namespace and global scopes, deny and log actions, policy ordering, richer matches, and layer 7 policy. I could drill into each of those, but given the timescales, I'm going to just focus on how important namespacing and global scopes and denies are. We've all heard of shift-left security, the idea of allowing your security teams to take responsibility for a high-level security approach and allowing your project teams to manage their own security alongside the project they're building. And that gives us lots of benefits for the organization. Well, using a combination of Calico Global Network Policy and Kubernetes or Calico Network Policy, you can see in this diagram a really nice use case is to allow your security team to manage the global network policy at a very high level, and then allow your project teams to manage policy individually within their project namespaces. So in this example, the security team has mandated, for example, that metrics collection is allowed and that DNS is allowed, but they've blocked some other things. So this presents a situation where your project teams can be agile, they can implement their own security alongside their project from day one, and yet they have some guardrails in place to prevent them from making foolish mistakes. Okay, that's all I have time for, so I'm going to do a quick demo. We're going to build a 3-tier application with a web GUI, some business logic and data. It's called Yet Another Online Bank. Now this is a really quick version of this demo, so if you'd like to see a more complete version that takes a lot longer to dive into the points, please go to our documentation and you can find a version of this demo alongside some really cool free courses which can help you with understanding CNIs and network policy. So with that said, I've got a 3-node cluster running an old version of Kubernetes because this is a lab environment that I built. I have Calico present as the CNI. I have the usual Kubernetes components and the Tigera operator, which is the method for installing the Calico on a cluster. And finally, I have Yaobank, the application. So with that provision that I said this is a really short demo, I can quickly just show that I can ask the customer component of the demo to give me some banking information. It's obviously not real banking information. Now, what if the customer pod, the front end of this application, was hacked and it tried to access the database? Well, in a vanilla Kubernetes cluster with no network policy and the CNI that hasn't implemented network policy, you can see that the front end is able to access the full database, which means a hacked front end could be maliciously used to dump the database. So what we're going to do is we're going to put in some policies to prevent that. The first thing is we're going to deploy a network policy that protects the database, allowing access only from the summary pod. The next thing we're going to do is to put in place a Calico network policy. Now recall that that's recognizable by this API version project Calico and global network policy. And that's going to protect and say that basically all namespaces can't access anything unless they're explicitly allowed, unless they are the kube system or Calico system namespace. And then we're going to put in place a specific rule to allow DNS. And some remaining network policies. Now I'm really low on time, so I'll just show you again that I'm still able to access the database through the summary and the customer pods in the way that an application user would do so. But if I try to access it again from the customer pod directly, it's blocked. I pressed Control-C here in the interest of time, but you can see it was timing out, so that basically means that the customer pod was not able to directly attack the database. So that's all we've got time for. Obviously, like I said, I hope this has been interesting to you, and you can check out this demo yourself by going to the Project Calico documentation. Last thing to say really is my contact details. I'm Chris Tomkins. I'm the lead developer advocate at Project Calico, and there's lots of ways to reach me there. So I hope you found that useful. Thank you so much for attending this talk, and I hope you find the rest of PlatformCon enjoyable.